Good day, everyone. My name is David Williams, Executive Director of the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Northeast Decarbonization and Regional Electricity Sector Integration. We are grateful to Pierre-Pineau from HSA Montreal for today's timely discussion. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues among professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations, along with a host of other products and services that you can find on our website at www.iaee.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regard to today's webinar before I hand things over to our presenter. First, this webinar is being recorded for those that cannot participate in today's live event. If you have questions for our presenter, please click the Q&A button at the bottom of the Zoom window and type your question. We have allocated sufficient time at the end of the webinar to address your questions. And now I would like to introduce you to our presenter, Pierre-Pineau, Professor and Chair of the Energy Sector Management at HSA Montreal. Pierre, over to you.
Thank you very much, Dave. So thank you for joining the webinar. I'll start sharing my presentation right now so that we can start. So I'll be talking about Northeast decarbonization and regional electricity sector integration. My presentation is really based on a report we recently released that I co-authored with Simon Langlois-Bertrand from Concordia University. This report is looking at opportunities and challenges for regional electricity integration, and it's part of the larger initiative, the Northeast Electrification and Decarbonization Alliance, that is trying to promote collaboration among jurisdictions in the North America Northeast to achieve deep reduction in greenhouse gases through almost 100% renewable energy system. So I invite you to download the report if you're interested. And here's the link to the full report. But basically, you'll get the essential of the report in this presentation. So the webinar outline that I'll be sharing with you is the following. First, we'll talk about climate targets and electricity policy in the Northeast. Then we'll go over the benefits of greater coordination and collaboration in renewable energy deployment and in electricity market in general. But then we'll also mention the barriers to greater regional cooperation, again, always with a focus on the Northeast. So these will be the 3 main points. I'll be talking for about 20 minutes, and then we'll have the occasion to discuss a few questions. So I'll be happy to go through the questions. Our focus today is really on the Northeast, which is this region that you see on the map, where you have the Canadian provinces of Ontario and Quebec and the Atlantic provinces, and of course the more populous region of New York and New England. This region has many interesting features, and we'll go over them in the next slides, but they are united in at least one organization, the Northeast Power Coordinating Council, which is a reliability organization, a power sector reliability organization, looking at the reliability standards. So there is some meaning in looking at that region as a whole, because there are already some joint institutions. But that's not the main reason why this region is interesting. From a climate perspective, the Northeast is really engaged in deep reduction in greenhouse gases. Most of the states and provinces in that region are signatories of the Under 2 coalition, aiming at 80 to 95 greenhouse gas reduction below 1990 level by 2050. And despite the fact that that's like only an official signature with no bounding targets for under this agreement, there are real policies in the Northeast that prove that not only politicians are shooting targets at voters, but they're also deploying real policies to improve renewable energy production in their jurisdiction. Capping emissions, that's the region where you have two cap and trade systems, the Regional Greenhouse Gas Initiative in the US Northeast, which is centered on electricity, but you also have the Western Climate Initiative in Quebec and Nova Scotia being a smaller Atlantic province in the Northeast, but still this WCI cap and trade is covering almost all the emission sectors, all except agriculture and waste. But this is a strong cap and trade system that is, in the case of Quebec, tied to the California cap and trade system, the WCI. There are lots of clean energy funds that are actually spending the money collected through the auctions of the emission rights sold in the cap and trade system. And then, of course, you have initiatives like the Reforming the Energy Vision in New York, that is a very ambitious initiative to green the power sector and reduce greenhouse gas emissions in a way that has never been seen in the past. Massachusetts in itself has clean energy goals with already different requests for proposal that have led to different contracts. One of these contracts, we'll come back to it, is a contract with Quebec, which is a 20-year-long contract for almost 10 terawatt-hour of electricity from Quebec to Massachusetts, which is so a real long-term contract that is within a policy to reduce greenhouse gases. So there are strong commitments in that region, and there are, so that's another reason why it's interesting to look at that region, is because there's a group of states and provinces that share some common goals. And if you look at the rest of the North American map, you don't see such a tight group of states and provinces that are so engaged into greenhouse gas reductions. So that makes a very interesting case study. If we look at the greenhouse gas emissions in these different states and provinces across in the last almost 40 years, then you see there is already a declining trend in greenhouse gases. And if we go by the target they have for 2050, then these greenhouse gases should decline even more in the future, and there will have to be significant changes in the energy system, but also in the power system. These are the global emissions, the overall emissions, all types of emissions included in these 5 different subregions: New York, Ontario, New England, Quebec, and the Atlantic provinces. What is noticeable here is that you see a peak of emissions around 2004, 2005, and then a decline, a significant decline in New York, Ontario, and New England. That decline is largely explained by the shift of coal in these regions. And if we look at the global US data, there is a peak level of consumption in coal around 2005, 2006. And that's really, of course, related to the low natural gas prices. And you see a decline from emissions in the power sector from coal. And that corresponds to the overall decline in emissions in these different regions. Quebec doesn't have coal generation, as we will see, and therefore the decline in emissions is not as visible in Quebec, but a large share of this decline in New York, Ontario, and New England is explained by this decline in coal emissions. And as you can see from the top line on the graph, the total US generation remained constant or very stable despite the decline in coal generation and emissions, because natural gas took over with not a significant increase in emissions, because natural gas is, of course, much cleaner and less emitting, and also because more renewable power came online after 2005-06, so that contributed to generation. If we look at how the generation mix has changed in these 5 different regions, then we see that there are significant changes in the mix. In New York, for example, so here you see the generation mix in 1990, and then in 2017 in the US case, or 2016 in Canadian provinces. And you see basically coal being phased out everywhere, so that coal in New York, New England, and Ontario has been removed from the generation mix over that period. Natural gas improved by a lot. Nuclear took some more space, and you see wind appearing. The gray box on the right bars is wind, and you see wind appearing in many regions. What I like to point out is the significant capacity installed in Canada compared to the US in terms, when you look at the total generation and the population. For example, look at Quebec. We are a relatively small province. Quebec is 8 million people, but we generate more electricity than New York or New England. And that electricity generation has been growing significantly between 1990 and 2016, meaning that there's a lot of new hydro that came online that is available for Quebec needs, and to some extent, and already being exported to New York. About 10 terawatt hour is being exported every year to New York, and about 10 terawatt hour is being exported to New England. These exports are beneficial to both Quebec and, of course, New York and New England. That if they were not beneficial, they wouldn't happen. But now, you know, given the need to decarbonize further, there are reasons to consider why shouldn't there be more trade and more integration and collaboration to make that power mix being used more optimally to meet the needs, especially since you've seen the growth in natural gas generation, and it's very clear that in New York, New England, and even Ontario, natural gas is a significant share of the electricity mix. But if we want to decline, if we want greenhouse gases to decline further in the next 30 years, that natural gas will not be able to stay, because with 80% decline in emissions, you will have to see some of that gas, probably all of that gas, going out. And the second trend is if there is decarbonization, there's a very good chance that electrification will increase electricity demand in that region. And if electricity demand is increasing, there'll be an additional challenge in terms of where will that electricity come from. And to add on that, nuclear power is not, is in some states like New York and even New England, nuclear power is on the phase out, or there are discussions to phase out nuclear. So that's an element that should also be taken into consideration. On one hand, these different subregions have very high goals in terms of greenhouse gases decline, and they don't, and the electricity sector is key to that decline, has been in the past with the phase out of coal. And if we want further decline, there will have to be some significant decline in the power sector. And in addition, there'll have to be there's likely to be more demand, and if there's more demand, there's probably a need to have a renewed electricity sector organization and more collaboration, and we'll come to that. Just to give you another glimpse on the differences between the different state and region, and the asymmetry that we see in that regions, just look at the per capita generation and consumption. So New York and New England generate per capita less megawatt hours than they consume, so that means they are net importers. But if you look and if you compare with Quebec, Quebec per capita is generating and consuming a lot of electricity. And why is that consumption level that high? It's because the hydropower that is generated in Quebec is extremely cheap. And when the price, and then because it's cheap to generate, prices which are still regulated in Quebec, prices are very low, and of course that sets a signal to consumers, and then consumption is much higher than what it could be if a price level was higher, and that would provide some signal for energy efficiency, and there could be some readjustment. And these readjustments would lead to savings in hydroelectricity that could, in principle, be exported and served in addition to other power sources to meet the need of different regions. So there is a lot of asymmetries in the regions in terms of consumption, generation mix, which is a very good ground for collaboration, because when there are differences, then that's where you can find mutual gains in terms of trade and exchange. So that leads to a strong rationale for greater coordination and collaboration in electricity markets, but specifically in renewable energy deployment, because there are a lot of synergies if you integrate different regions. So there's a long literature on the benefits of electricity market integration. And these generic benefits are not directly related to renewable energy. So even if you don't want to do more renewable energy production, these benefits are true. And this list of benefits comes from the UN, from the World Bank, the CECs, the Commission on Environmental Cooperation, that is an institution related to NAFTA, the North American Trade Agreement. So these benefits are really generic benefits of electricity market integration. You have better reliability and pooling reserves. You can reduce investment in generating capacity because you have access to more capacity in other regions. You can improve load factors and increase demand diversity, which again enable better use of the existing assets. You can have bigger construction and benefit from bigger economies of scale. You have a greater diversity in the generation mix. And could have some significant benefit for supply security. Economic exchange, if you integrate, you can do more of this exchange, and that will become even more important when you have additional wind resources in your mix, because if you cannot move that wind to another place easily, then you may just lose that wind generation. So economic exchanges are key, already in the current power sector, but if you can improve these economic exchanges, there is even more benefit. Environmental dispatch and new plant siting can also be better done in a larger area because you have access to more options and you can select the best options, and you can also better coordinate maintenance schedules. So this is a list of generic electricity market integration benefits that are very important, and many jurisdictions around the world have realized that, and they've said, well, we should open and harmonize our market designs across different regions. New England being one example of a group of states that have decided to create a single ISO to manage their markets, their different electricity markets, and into a single one. But if you compare New England, with its about 15 million inhabitants, to what Europe is doing, for example, and creating to harmonize across all countries and to create a very similar market and pushing for more transmission, then North America, and especially at the Northeast, are way behind in terms of integrating their market. And given the fact that, as I just said, we have very strong and ambitious greenhouse gas reduction goals in the Northeast, we should really consider these benefits as being key to attaining our objectives. So these were generic benefits. In terms of renewable integration, there are also lots of studies documenting the need for more integration, more transmission systems, more transmission lines, but not only transmission lines, these are the hardware. We also need common institutions to actually manage the exchange and make sure the price signals are the same across the regions, and that reliability rules are the same, that capacity markets are also similar, that renewable targets can be shared and traded so that there are real benefits to trade. And all of these papers are just a sample of papers showing you that these benefits, if you want to decarbonize the economy and the grid, you need a more integrated grid, to just reuse the title of the EPRI 2014 document. But there's been a lot of studies, very general, but with specific results on the benefit of having larger areas to integrate more renewable in a decarbonization context. There has been more specific studies, and here are a few specific studies, some of the Northeast, some on Canadian, on the cost. If you want to decarbonize the electricity system, there has been some specific studies on what are the benefits if you trade more between different regions in terms of capacity savings, in terms of transmission needs, in terms of cost impact. There are a lot, well, there is a growing literature to estimates of these costs. A recent one is the MIT paper that you see there, and we will have soon our own contribution into that debate in a paper that we recently submitted, and it should be available in a few months. So there is a strong literature showing that there is, academic literature showing that there are some benefits. And it even goes beyond the literature. Even politicians in the Northeast do recognize that there are gains in cooperation. And so, for example, if we look at a quote from a recent conference of New England governors and Eastern Canadian premiers, they basically set to themselves as a goal the idea of having to diversify, strengthen and diversify the generation resources mix and storage capabilities to reduce energy cost pressures. So this is, again, not all the governors and premiers of the Northeast, but a good set of them. They do recognize that, and they try to work to a better system. In New England, there's a recent commitment to regional cooperation on energy issues to basically study what could be done to improve the energy system to achieve these greenhouse gas reduction targets. However, looking at New England is of course good, but the real benefits may actually come from a greater area where you have more access to hydropower and storage, as it's been mentioned in the first quote here. And that has to be considered because the scope of the challenge is such that if you don't look at all the options, then you may very well end up with a very costly renewable system, much more costly than what some alternatives could be. And despite all the literature and despite the growing recognition in political sphere that there are some gains, things don't work out now in terms of collaboration. Just think about these transmission links, all these proposals to bring power from Quebec to the south, to mostly Massachusetts. There's been a few proposals, some of them just completely fell out and could not continue. One is still being discussed. The New England Clean Energy Connect is the one that is the most likely to be built at this point. But these examples are just a sign that there is no collaboration. There is very limited collaboration and cooperation among the different states to actually reach a target that Massachusetts has set, but cannot count on the other states to basically collaborate fully to make that project happen. And it's really a regional problem because there are solutions, but we cannot get the solution being implemented. And this is a problem because if we cannot get these relatively big, but in the scope of what has to be done, small project, then if we cannot do this relatively small project, well, achieving 95% reduction by 2050 will be very, almost impossible. So we need to go over these problems and find common solutions. So what are the barriers to regional cooperation? So this is because this is really the problem we've been facing in the last years, is that there has been extremely little regional cooperation in electricity power. Yes, there's a lot of trade and export and imports, and there are reliability institutions, the NPCC, a joint reliability institution that is looking at very technical reliability issues, and it's very important to have them dealt with, but there are more into the planning. So what are these barriers? And our document basically go over these barriers to try to explicit them, make them explicit, to be in a better position to overcome these barriers and go towards more integration in the region. So one of them is these institutional and organizational barriers. We do have, both in Canada and the US, federal governments that have some say in the electricity sector. And they have, but states and provinces have a bigger say in these in the electricity sector. Most of the power in terms of electricity market design, in terms of how the industrial structure of the electricity sector is being decided, lies on the state and provinces. They are the ones deciding what to do. And they all decide something different. Ontario has decided something, Quebec has decided something, New York has decided something, New England has decided a different market design, and the Atlantic provinces too. So that leads to a lot of different variations in terms of systems design. And the federal government doesn't step in to say that doesn't make sense. In the US, at one point, the FERC, the Federal Energy Regulatory Commission, tried to have regional transmission organization, RTOs, to make some order into this design, to have like similar market designs across the US and Canada. But that failed because some states and provinces, but mostly states, decided they weren't happy with these RTOs. But that would have been a step towards a better integrated system. That fell in the past, but that will have to be completed if we want to achieve a low-cost decarbonization or lower-cost decarbonization, deep decarbonization. And so that diverse set of institutions basically lead to so many regulatory agencies and system operators that do not have a mandate to collaborate and plan beyond their borders. So they do what's needed within their borders, and that's their mandate. And if they want to go further, then they are blocked by just their simple mandate, even if they want to. So we should give them a mandate to basically look at possible ways to collaborate and to find better solutions for our next 30 years in the electricity market. And then, of course, to make things even more complex, we have a set of competitive markets and regulated markets. Quebec and the Atlantic provinces mostly have strongly regulated markets with very little competition. There are some private actors and there are some level of competitions even in Quebec, where the the generation sector is not only occupied by Hydro-Quebec, but the smaller private producers are much smaller, and the competition level is not as high as in New York or New England. So there are issues there, but even New York has its own share of issues. You know, if you look at hydropower in New York, for example, it's mostly owned by the New York State, and it's not competitive. The hydropower in New York is not competitively sold into the market. So that would be another kind of reform that we would probably wish to see happening if we wanted to harmonize across different states and provinces to have a more level playing field. So these are a set of issues. Of course, there's a higher level set of issues, the political barriers. Regional cooperation is conflicting with industrial policies. Very often politicians try to sell renewable energy as a tool for economic development, of course, local economic development for local green jobs, which of course we all want. We all want economic development. We all want green jobs. But this is coming into the way of an optimal design of the improvement in renewable supply, because if you just look for the local solutions, then you may miss better solutions elsewhere. And in all the models and papers that you've seen, you know, the scope of the renewable energy that is needed in terms of solar, in terms of wind, in terms of more interconnection, make it such that there is a need for more renewable energy everywhere. There's not a single province or state that will just be the lonely supplier of energy for everyone. But if you just stop looking at the best options because it's not within your state or province, then you will lose many opportunities. So that is coming a problem, and you have programs in New York and in Quebec that are giving, you know, lower rates to some businesses, basically on industrial policy grounds, to basically favor some some companies. And of course, there are a lot of good reasons for doing these projects, but that creates some asymmetries in prices and disincentives to basically use the electricity at the best place, at the best moment, because you don't have the same price signal for everyone. So again, industrial policy is very often coming into the way of regional cooperation because many customers are very jealous about their access to cheap power, and that may be something to reconsider if we really want like a fully open and transparent regional cooperation and regional system. Then there are, of course, the social acceptance barriers. Local opposition from populations come from different angles. What are the economic impacts about green jobs, for example, the environmental impacts? Some people don't like to see hydropower in their backyard because of course it does have environmental impacts, much lower environmental impacts than many alternatives like natural gas or even wind in some cases, but still there are environmental impacts, and sometimes not in my backyard is preventing the way to some of the good systems. Social impacts in terms of how it does impact the life of many people, especially First Nations in Canada and the US. First Nations are very often very impacted by these power supply development projects. So we have to consider these impacts because we cannot just ignore them. But basically, we also have to realize that the local opposition should not get and prevent the larger goal to be achieved. If we cannot reduce our greenhouse gases because of a set of multiple local opposition, then basically no one will gain. Even the local people will lose in a world where climate change is much bigger than what could be. And the visual impact is also on the list of the reasons why some projects are opposed. Coming back to the New England Clean Energy Connect project, some of the people who are opposing that are environmental groups, not liking for some reasons the hydro from Canada, despite the well-documented impacts of the hydro, and then with the lower impact than many other sources, almost all other sources, there are still ways to oppose these imports. Local renewable energy producer associations, they oppose the project, and incumbent companies also don't like that, especially natural gas companies or producers. The power generators from natural gas, they all see that competition coming, and they want to protect their market for their own reasons, which of course we can understand. But again, to achieve the higher goal, then we will have to move beyond these problems and find solutions to generate social acceptance. So how to move forward, and I'm soon finished with my presentation, there has to be a special attention given to regulatory and market discrepancy across jurisdictions. We have to look at the set of institutions that we have and see how we can get more harmonized institutions, because we won't survive in a world where we have so many rules, so many different bodies saying so many different things, when our companies in the region, they have a high operating cost. If they need to change their operating systems to meet the rules of all the different jurisdictions, it will be hell. So we have to take a hard look at these differences and try to get a more level playing field in the region. We need to decouple industrial policy from renewable investment. This will happen. I mean, renewable investments will create jobs and will be good industrial policies, but we should not be protectionist about that, because it will be a problem and a barrier to the best integration possible. And also we should of course take all the legitimate concerns of citizens that have good reasons to oppose some project. We should take them into consideration, and we should find ways to solve these issues. And it shouldn't be on a burden for companies behind projects. There should be a higher level, government level, who is dealing with these issues, because some of the projects, if they were designed and planned from a higher level, then they would be fully legitimate, and there should be some help in dealing with these issues, because most of these projects are very often for a common good in terms of greenhouse gases. Of course, they haven't been prepared and planned from a higher higher level of planning, because that higher level of planning doesn't exist across the region, but there should be a development to have higher level of planning and then higher level of defense for this project. So in conclusion, decarbonization will require strong power systems. The current patchwork of power system is recognized to be incompatible with the future needs. We know that, it's been documented, and all the references to the studies I've shown briefly mentioned are given in the full report. And therefore, there should be a regional dialogue that has to be started to set up some joint electricity institutions on a truly collaborative mode in the Northeast. Of course, that would be true for everywhere in the world, but in the Northeast, there are opportunities that are not found in other places in terms of access to hydropower and storage, existing storage in dams, shared goals in terms of decarbonizations, already strong policies for this decarbonization. We already talk and exchange a lot, so why don't we move beyond and create the right framework to basically harmonize the electricity system and find a way to meet our goals when we all know that the electricity sector will be the cornerstone of the future decarbonized system. So thank you very much. Again, if you want to download the report, you can go to that website. And the chair in energy sector management at HEC Montréal is supported by this set of companies that I would like to thank again. So I will stop sharing my screen to have access to the Q&A session, and start to answer some questions. So please feel free to type questions. At this point, I just have one, so I encourage everyone to answer, not hesitate to ask questions. So Churchill Falls in Newfoundland is a big power project in Newfoundland with 30 terawatt hour for generation per year, and it's considered to be, it's considered to be an import from Quebec, even though it's depending on what documents you look at. If you look at Hydro-Québec, it's not considered to be an import into the Hydro-Québec system. But if you look at Statistics Canada and how it deals with interregional exchange of electricity, then it is an interprovincial exchange of electricity from Newfoundland to Quebec. So that important share of 30 terawatt hour is considered to be an import in many cases. Okay, I have a question, another question. Oh, I have now a lot of questions. Oh, I just didn't see them before. Do I see the WCI cap and trade system expansion to the Northeast, the expansion of the WCI as an option to increase renewable cooperation? So the WCI, the cap and trade system in Quebec and California, could in principle be expanded to New York and New England and any other states that would like to join. I think that's a different topic from electricity market integration. I think it would be beneficial to have, of course, a one unique cap and trade system, but it's very difficult to harmonize that and to have that common cap and trade system. I think we'll come to that at one point, but it's a very different negotiations to have compared to the electricity system. I don't think we should tie them too much, although in an ideal world we would tie them, but they're different. In a future decarbonized Northeast region, should Quebec and Hydro-Québec strategically limit their production increase of intermittent electricity and instead eventually increase their hydro production with reservoir to make sure they can provide stable electricity when needed to New York and New England? So no, at this point, Hydro-Québec has a lot of storage. And if you look at the study, the MIT study, and you'll be able to look at my own study of the region, then we don't need more hydro. What we need to have is more wind and more solar to some extent, but especially much more wind and more transmission, because the current storage in current hydro reservoir in Quebec are largely good enough and to provide the balancing tools to store the electricity for the wind surplus and then be used when there's no wind. So the current existing reservoirs are good enough. We don't need to increase more hydro, given the cost of the new hydro and the low cost of wind. So what we need to have is more access to these reservoirs, basically through more transmission and more wind. And there's more wind. There will have to be more wind everywhere, not only in one single state or province. We have been discussing collaboration for years, and for years it does not result in a major coordinated advance. What could make it change in the next 5 years? So that's a good question. What could change and what could make people think that we need to move is that we have strong 2030 targets. So we have 10 years in New York, in New England, there are deadlines for 2030, and there's a lot of new renewable power that is being asked. So we need to meet that. We need to have this something happen. And if we look at New York and Massachusetts and many other states, they do plan for some offshore wind, which are great projects. But even with that offshore wind, there's a need to collaborate and to have more transmission lines, to have two-way trade, and to basically be able to use that electricity when there are surpluses of wind in other places, and when there's no wind, because even with offshore, even if you have very high capacity factor, then you don't have wind 100% of the time. So you will need some backup power, and that backup power, that storage, can be the hydro from the Canadian reservoir. So that should be interesting, and that should be one of the motivating factors to reach our 2030 and beyond targets. If we can't even get a deal, another question, if we cannot even get a deal and find common structure with Ontario, how can we expect to conclude agreement with the US? So that's a good question. It's very hard across Canada to find common institutions. So I'm not saying it's easy. I'm not saying that it will be done. The only thing I'm saying is that we know it would be good. We know it's essential to meet the target, and we know we should do it. So we should basically find new ways of negotiating, new ways of seeing things. All the studies that I've mentioned are providing new numbers, new evidence that there are gains. So we should keep providing these numbers to policymakers, to the industry, to government, to the population in general, to show that there are benefits, and we should tell the population that these benefits will be shared so that everyone will be better off. We can be in a system where everyone is better off, because at this point, we are not using our market optimally. Are there university think tanks similar to the chair active in other territories? Okay, so, well, of course, in Ontario, at Western Ontario, you have an energy center. In Boston, you have the MIT with very good research centers. In New York, you also have a lot of good researchers in good universities. So, so I haven't seen this, besides the MIT paper on two-way trade with Quebec, Ontario, and New England that I've mentioned in my talk, I haven't seen much papers looking at the Northeast from other universities. So I think there's a need to have more researchers looking at that. But there are, of course, lots of research and people looking at some energy issues. Could you discuss political, economical incentives that could be used to make regional, provincial regulators talk to each other rather than focusing on their own jurisdiction and political clientele? Well, there has to be some pressure from government, from utilities on their regulators to suggest to them what to do. So basically, we should tell our regulators, look, we have a problem for 2030. Things are okay now, but if we look in 5 years or 10 years, when we should have much more wind installed and much lower emissions, greenhouse gas emissions, there is a problem. So we should make that problem known to regulators and tell them, if you don't deal with the problem now, it will become worse in the future. So please be kind and start talking about collaboration, start talking about possible ways to have more joint regulatory bodies to have a better system. And there are platforms of collaborations like the NPCC that I mentioned. And the NPCC, the Northeast Power Coordinating Council, they used to have a regional planning forum. If you go on their website, there is a section which is called Regional Planning Forum for the NPCC region. The last time they met is in 2003. So that's like almost 20 years ago. So I don't know what the NPCC is doing, but they used to talk about regional planning, but they don't anymore. So we should tell them, well, please do talk about regional planning, because that is very important in a decarbonization context. Is Hydro-Québec planning to tap on Muskrat Falls to add to its export supply? What is the status of Gull Island? Is Hydro-Québec going to partner with Nalcor to build this dam? So these are very interesting questions. There are at this stage, I'm not from Hydro-Québec, I sometimes discuss with them, but I'm in no position to tell what's exactly happening. But as far as I know, there is no plan for Hydro-Québec to be involved in Muskrat Falls, which should be completed this year. This has been a disastrous hydropower project, which is late to be completed and cost probably 2 or 3 times more than what they planned that it would cost. So I don't think in the short run it will be part of Hydro-Québec's mix. But of course, if Hydro-Québec and Nalcor were working together in different ways, then that could be at a huge benefit for everyone. So ultimately, I think there will be some kind of discussions. Hopefully there'll be friendly discussions and not through lawyers and courts like it's been in the past. But again, there has to be some political signals to make them talk more and plan in a more rational way instead of planning in isolation. Okay, I'm taking some other questions. We still have 15 minutes, so we have plenty of questions and I have 15 minutes of time. Protectionism appears to be the order of the day. How do you envision future collaboration? And it's true that protectionism is strong, and especially with COVID-19, people think of being autonomous in all types of things. We want food to be all local. We want pharmaceuticals to come all from local sources. We don't want to depend on China for masks. We want everything to be local. The truth is that we won't be able to have everything coming from local sources. So we have to agree that, trade is and will still be good. And given the scope of the challenge, then we need to integrate in the power sector, because there are significant cost savings to be made. And these cost savings should be put in perspective in the public debate. Yes, a transmission line is not the nicest thing you want to see outside of your window, but if we don't have these transmission lines, then power will be much more expensive. And yes, there will be rooftop solar in many houses, but that will not be sufficient. And even if we have more power walls, that will not be sufficient. All the modeling exercises that I've mentioned, they all show that yes, we will have battery storage, we will have rooftop solar, but that will not be sufficient. We will need some transmission line, a backbone transmission system that will have to be much greater than what we have now. And we will need joint institutions to manage the network. Otherwise, it will be hell. It will just prevent things to be done, because everyone will try to look for its own interest in the short run, and we won't design strong long-term institutions that will benefit everyone. From one of the slides, it appears that consumption per capita in Quebec is very high compared to other jurisdictions. Can you explain why, and what do you think we should put more effort, and do you think we should put more efforts in reducing consumption in Quebec? So the reason why there's much more consumption in Quebec, it's really, again, the cheap hydropower. We have large volumes of hydropower at a very low cost. The average production cost from Hydro-Québec is 2 cents per kilowatt hour. So that's the generation cost. The average procurement cost of hydropower from Hydro-Québec production, 2 cents per kilowatt hour. That's very cheap, so it results in very low prices. So these low prices, they've attracted lots of industries like aluminum smelters. So we have a huge aluminum production in Quebec, and we've also electrified our heating in Quebec. So with the low electricity prices, close to 80% of residential buildings in Quebec are already heated with electricity. And with resistive heating, which is of course not the best technology to heat, and yes, we should reduce consumption in Quebec by having much stricter energy efficiency standards for buildings and be much more aggressive with industries in terms of energy efficiency programs. So there should be a lot of savings through energy efficiency that could be made in Quebec. That comes at a hard psychological cost because people don't like to change. So we will need to, shake a little bit the habits of customers. But once we've shaken these habits, we could generate a lot of savings that could be used for other purposes. If we do agree with neighbors, we may export these savings. And if we don't agree with neighbors, Quebec will find other ways to use these savings. But in all cases, there are better use of green electrons than just heating a basement where nobody lives during the winter. US ISO requires energy supplies to be documented as to where the energy is coming from. How are Hydro-Québec and Nalcor going to tag the electrons from its 60-plus system in order to satisfy ISO in the US? That's a good question. That's basically Hydro-Québec could probably tie, like it's been done in the US, generation from one source to some sales in some other sources. So RECs, there are ways to tie electrons. So Hydro-Québec knows which plant is producing when. Now, so maybe in the end, Hydro-Québec will have to make some specific contracts and to say, okay, that supply to Massachusetts comes from this hydropower plant, and there, Hydro-Québec may in the end may have to do that. It might be difficult to do, but it's still feasible. If we look at the overall balance and trade from Quebec, there are imports, but these imports are mostly, as we've mentioned, from Newfoundland and Labrador and Ontario. So these are the two main import sources that Quebec uses. Ontario at night, so it's nuclear power and wind power from Ontario, and hydropower from Labrador, Churchill Falls. So it shouldn't be too difficult to prove that the electrons coming from Quebec are 99% green from wind or hydro, but then there could be some paperwork, additional paperwork to do if really we want to tag every electron, and again, there should be limits to how much we want to tag things, because at one point it's not productive. So in my conclusion, I mentioned joint electricity institutions, and someone asked me what examples do you have in mind. So there are many examples. If we look, for example, at Europe, Europe has, at least some organization where regulators would meet and discuss. So they would have like collaborative processes where regulators would meet. Transmission companies and system operators should also meet in a single location and have joint planning meetings. We don't have to merge all of these systems into a single one initially, but at least they should develop their planning and standards jointly. So Europe, I'm not saying that we should do everything like in Europe, but what I'm saying, we should look at how Europe is designing these joint institutions that do bring together transmission operator, systems operator, regulators, and they follow the integration of the grid. There's one thing in Europe that we don't have. They have a higher government level that pushes joint institutions. So there are some market, integration market laws in Europe that compels countries to collaborate. So I'm not saying we should have this higher level, but we could do like the Nordic countries did. Without a higher level, Nordic countries have been able to develop joint institutions, and basically they've looked at what Norway did in terms of deregulation, their electricity sector, and Sweden just adopted similar rules to the Norwegian rules, and Finland and Denmark followed. And basically these 4 countries, they just adopted and negotiated joint rules without having a formal higher level. So it's really in transmission planning, in market designs, in renewable objectives and how they define renewable energy. There should be some joint discussions in the region to have joint institutions. Okay, I'll go down. Can you say more on your vision of a legitimate process to address citizens' concerns over transmission line project? We have a body in Quebec called the BAP, which is a bureau for public hearings on environmental issues. Could that be a regional? Could there be a regional agency? In my view, well, I've never really thought about the exact institutions that we should design to hear the concerns of the citizens' concerns, but yes, there could definitely be some joint institutions. For example, I mentioned very briefly NAFTA, the North American Trade Agreement that was set up years ago, created the Commission on Environmental Cooperation for North America. So it happens to be in Montreal. We never hear about that institution, but in principle, we could set up these institutions, and we could use them and make them useful. So the Commission on Environmental Cooperation, I would say, with all my respect to them, they're mostly useless and unheard of, and they don't have a big role, but they could play a bigger role. So we could think about joint institutions to hear concerns of everyone in a single place, instead of having Quebec hearings and then hearings in Maine, and then hearings in Massachusetts, and hearings in New Hampshire, and hearings everywhere, without a central agency. And of course, the board of such joint organization should be composed of people from New England, New York, Ontario, Quebec, and Atlantic provinces. So if we have a very diverse board, then we could set up some joint institutions and move forward in a way that deals with all the issues in a single place. Do my study assess the potential impact on electricity rates for the jurisdictions that should be integrated? So yes, we do look at the rate impact. Well, not the final rate impacts, but we do look at the wholesale price impact if we integrate. And of course, the bad news for Quebec consumers is that if we integrate more with our neighbors, then of course the low electricity cost, wholesale cost of electricity in Quebec can only move higher, because that's the laws of trade. When you trade, you go to a higher level, and a higher level for the exporting jurisdiction and a lower level to the importing jurisdiction. So that's, people trade because they all benefit. So despite the higher level in Quebec, or in some cases in Ontario, this is beneficial because the exporting provinces will overall make more money and be richer with this trade, and the importing jurisdictions overall will pay less for the same amount of energy. So it's a win-win situation. That's like basic 101 economics. Trade is good, so we should optimize trade, and you end up with a more efficient system. And in principle, you can design some transfer payments to compensate everyone. So we should look at these issues because they are key. If you want to convince the Quebec population that integrating more is good for them, we should be able to explain to everyone how it will be good and how can they be sure it's going to be good. Okay, let me try to find questions. Can you talk about the role of distributed electricity production versus large scale? Yeah, I did briefly mention distributed generation. There's room for that. But when you look at big cities like New York, Boston, Montreal, and when you look at industrial load, which is significant. So if you take like big cities load and industrial load, you cannot meet that load with distributed generation. You need utility scale wind farms and solar farms and biomass projects and hydropower, of course. So you need large scale, because only distributed generation will not meet the needs and the load of many of large cities that don't have enough roof space to meet their load, and industries. So distributed generation will be key, but we should not think that distributed generation is the only answer, because energy needs will be such that we will need large scale, small scale, and much stronger and better integrated and designed grids. Transmission grids, distribution grids, they should be upgraded, and they should be upgraded in a harmonized way. Otherwise, we'll just miss the best opportunities. A last question I'll take. Because the main power line project could transit base load electricity at 90% of its capacity to New England, I understand that to storage huge amount of electricity in Quebec from wind power, more power interstate power line will be needed. Am I right? Yes. So that was a question that may not be clear to everyone, but the current New England Clean Energy Connect project is really, it's mostly for base load. So it's really a transmission line that is for exports to deliver electricity to Massachusetts. If really we want two-way trade and be able to use the wind when it's needed, it's more transmission lines in all different directions, more from New York to New England, to New York to Ontario and Quebec, more between Quebec and the Atlantic provinces. So in our study that is yet to be released, we actually do document in the model all the best transmission lines that we see under different contexts. So it's not a question of one province supplying other provinces or states. It's really a question of a group of states and provinces exchanging among themselves to optimize the system. It's really the systems that has to be optimized, and it's not about one single province or one single state. So transmission lines will have to be built. Currently, we probably have like around 10,000 megawatt of interconnections, Quebec with other provinces, and even more megawatt of transmission capacity between New England and Ontario and New York. But we should probably triple that, according to some of our results, to have the optimal transmission system, to have a 100% decarbonized grid. We would probably need to triple the amount of transmission capacity. So thank you for your attendance. There are some questions that I could not answer, so I'm sorry for that. I'll be happy to have a look at them afterward and maybe contact these people if I have a good answer for you. Thank you very much. Download the report, and I hope we'll have another chance to exchange in the future. Thank you very much.
IAE wishes to thank Pierre Pineau from HSA Montreal for an outstanding webinar. Thank you very, very much, Pierre. I know I personally learned quite a bit, so we're very grateful for your time and timely research. Fun listening. This webinar has been recorded for future download along with the PowerPoint presentation. If you're not a member of IAE, we encourage you to join by visiting us at www.iae.org. Thank you for attending, and I officially close this webinar.